Suppose we wanted to evaluate this integral, and suppose we wanted to do it by our method of substitution by matching. First of all, you're going to have to go through these steps, which can look quite daunting, but as you practice more and more, the steps will start to flow better from one to the other, and it'll become second nature to you, but it does require lots of practice. Before we actually get started with this, let's copy the problem back down again. Now we can just begin going through the steps one at a time. The more you practice this, the more it will all flow nicely. The first step is to set u equal to the expression raised to the power. In this particular case, that might be slightly confusing since there's more than one thing, obviously, raised to power. You've got 3x to the fourth. In the numerator, you've got the expression x to the fifth plus 1, all raised to the third, in the denominator. Whenever there's a choice that you have to make and you're not quite sure, I think this tip will probably help you. As you get further along, I think you'll see that it becomes a more natural problem. But in the beginning, you need something to sort of guide you. And I would give you this tip. If you're ever in doubt about what to choose u on the source of problems we're dealing with now, you probably should choose u to be the expression with the highest power. So in the numerator, you've got a 3x to the fourth, but in the denominator, you've got that x to the fifth plus 1. That's a higher power. That's probably going to be a good guide for you whenever you're thinking there might be more than one choice. So that's what I'm going to do. I'm going to let u be the expression x to the fifth plus 1. Step 2 says to compute du dx. That's just the derivative of u with respect to x. The derivative of x to the fifth plus 1 is 5x to the fourth. And then if we want to solve for du, which is step 3, we simply multiply both sides by dx. The dx is on the left, divide out, and you'll see that du is equal to 5x to the fourth dx. So we've done steps 1, 2, and 3. Step 4 says if the integrand has a numeric, which is just a constant or just a number, factor is a number that's multiplied by something else, move it to the outside of the integral. Now you notice there's a 3 there. Let's move it to the outside of the integral. That leaves us with just an x to the fourth in the numerator. Now this 3 out front is just going along for the ride. What we're actually going to be working with is this integral. Granted, that 3 will multiply our final result, but what we're interested in, other than carrying that 3 along with us, is that integral. Now looking at that integral, we've identified that u is x to the fifth plus 1, and that the u part, what we're calling the u part, includes the power as well. So the u part is the quantity x to the fifth plus 1 all cubed. And everything else is going to be part of the, what I call the du part. Now remember, we're just carrying the 3 along for the ride, but don't forget to keep doing that. So we'll write the 3 down. But we're looking at that integral, and step 5 tells us that we need to get the du part after the u part. So I know that x to the fourth is part of the du part, so I'm physically going to put that x to the fourth with the dx because I know that they belong together. X to the fourth dx, x to the fourth dx. Now, once I grab that x to the fourth in the numerator and there's nothing else up there, that's not going to do. I've got to do something, and what I do is put a 1 there, because if I put that x to the fourth back to where it was, 1 times x to the fourth is still x to the fourth, and I haven't changed anything. So if I pull the entire numerator off, I have to put a 1 there. So look at what we've got. We've got the u part right after the integral sign, and the rest of it is the du part. Now going back to number 5, it says to do just what we did, but then it ends by saying that if we need to compensate by a constant factor, we can. So we have to answer that question, do we need to do that? And you answer that by looking back down at the differential du in the lower left, and you'll see that yes, there's a 5 there that doesn't appear back in the integral. There's just an x to the 4th dx, but we need a 5 x to the 4th dx. So as a matter of fact, we do have to compensate by putting a 5 as a factor in the du part. So I will put that 5 there. I can do that as long as I compensate by putting a 1/5 on the outside. Look very carefully at that, because if you're confused about how that worked, then anything you do from here on will be a waste of your time because you're not following along at this point. So pause if you have to. Make sure you understand how we got there. And by the way, before we go any further, we might as well take care of the arithmetic here out front of the integral sign and multiply 3 times 1/5. Of course, that's just 3/5. Now you can see that we're ready to go to step 6, which is to actually do the substitution. Take the x's and dx's out and replace them with u's and du's. So what is u? U is x to the 5th plus 1. So out goes x to the 5th plus 1, and it's replaced by u. Okay, what about the rest of it? Well, the 5x to the 4th dx, what I call the du part, is in fact equal to du if you look down the bottom left. So all of that can come out, and we just call it du. So the 1 over something to the 3rd becomes 1 over u to the 3rd, and everything else, as you can easily see, is equal to du. So my substitution now is complete. No longer have any x's and dx's, I only have u's and du's. That's the goal of this whole substitution by matching, is to make things so that you can, in one fell swoop, get rid of all your x's and dx's and replace them with u's and du's. It's quite a trick. Now what? Well, remember, we're eventually going to use the general power rule for integration, but that applies to u to a power. This is 1 over u to a power. So what happens here? Remember, we're talking about the u to the 3rd as being the u part and the du being the du part. We substituted out of there, but that still does not fit the formula that we want to use. We want to integrate that integral right there, but the formula we have starts us off with an u raised to the n power, not a 1 over u raised to the n power. Turns out that's simple to solve because 1 over u to a power is just u to the negative of that power. So writing the 3/5 down again, I know that 1 over u to the 3rd is just u to the negative 3. Just basic algebra. So now the integral looks like something that I can deal with. So again, I'm just carrying that 3/5 along. Please don't forget to carry that 3/5 along. Your constant factors always get carried along. I'm going to now take the integral that matches the general power rule for integration formula, and I'm going to apply the general power rule for integration. It says when you've got u to a power, you can take the integral by adding 1 to the exponent, as long as out front you multiply by 1 over that exponent. Now be careful with negative exponents. If I add 1 to -3 plus 1 is -2. So be very careful with that. So it becomes u to the -2, and then according to the general power rule, we want to multiply by 1 over that power. So if -2 is the power, we've got to multiply out front by 1 over -2. Keeping in mind that that 3/5 is still sitting there. Also remember that, as always, with indefinite integrals, you have to add a plus c. We're close now. Let's do the arithmetic out front. Multiplying a positive fraction times a negative fraction is going to give me a negative fraction. And when you multiply fractions, you do top times top, bottom times bottom. So you get -3/10. And you still have the u to the -2, and you still have the plus c. We've done the calculus, we're basically done, but we're the ones that put the u in the problem. There was no u in the original problem, so we have to get rid of the u as the last step. Now I've run out of room down here, so let's just take that and put it up at the top and keep going from there. So as I was saying, I want to get rid of the u and put the x's back in. But that's easy enough because I know that u is equal to x to the fifth plus 1, so I just got to go back and put that in there. Take that x to the fifth plus 1, plug it in place of u, and you have your answer. Also remember that if you're at all unsure that you did it correctly, all you have to do is take the derivative of your answer and see if it comes out to be the integrand that you started with. So if you take the derivative of your answer and it comes out to be the integrand that I've circled there, then you can be very confident that you have the right answer. Practice is the key.